fifth graders. So today I want to go through what the Unit 7 post-test would have looked like to you. I want to give you the opportunity to assess your skills, own your learning. This is for you. You can see how well you would perform if you were given this in the classroom. And remember, the ultimate goal of an assessment is for you. So look this over. If you miss any skills, make sure you revisit it or fill those holes before entering fifth grade. So this is how number 1 and 2 would look. At this point, I want you to get like a piece of paper and a pencil, and you can try these problems. So you can pause it after I present the problems, and I'll try to do like 2 at a time, and then we'll pause, and then I'll show you the answers. So go get your stuff, get everything you need. And when you're ready, this is what 1 and 2 are asking. It says, write the answer to each problem. So the first one has 7 multi-digit multiplication problems for you to solve. And number 2, it says solve each of the problems below. So they want you to solve each one. Show your work. You can use any strategy that makes sense to you, except don't use repeated addition. All right, pause the video and go give them a try. So welcome back. Here are the answers to 1 and 2. 1, the first one is 160. The second is 420. The third is 300. The fourth is 2,400. The fifth is 4,000. The sixth problem is 860. And the last one is 990. For number 2, looks like they did a partial products for the first one. The answer is 306. The second, they did partial products too. Added them all together, and it's 1,796. And this one, they did the over strategy. So they did 10 times 321 and then divided it in half. You can use any strategy you want, by the way, for any of these. But the last one, the answer is 1,605. All right, let's go look at number 3 and 4. So I might have to move my head here. Oh, no, I don't. Well, it looks like number 3 is the last one on this page. So before we go to the next page, try number 3. It says choose one of the multiplication problems below and circle it. Pick the one that seems best for you, not too hard, not too easy. So one that, wouldn't come easily to you, and one that isn't so hard, it's most likely you're not going to get it correct. Choose that one you're super comfortable with, that kind of gives you a push. Solve it, and then come back to the video. So pause. And welcome back. Let's move my head over here. Let's go down a little bit, and I'm pretty sure I'll give the answers to all of them here. And your work will vary, whatever strategy you wanted to use. But if you chose the first one, it's 286. The second is 375. The third is 748. The fourth is 648. The fifth is 1,269. And the last is 6,324. And so moving across, for the most part, they become a little more difficult. All right, let's head to number 4. And I think I have to go back out. Here, we got to go like this. I'm going to have to make it bigger. Let's move this. All right, making it bigger, going up. So let's see, let's look at 4 and 5. Okay, so fill in the bubble to show the best estimate. So this one's looking at the skill of estimation for each problem. We know estimation plays a huge role in math because you should always be estimating, so you can be sure your answer makes sense and is somewhat close. So For the first one, for a 29 times 7, which would be the best estimation and why? And for 4B, it's 51 times 39, which would be the best estimation and why. Before you do that, I want to read number 5. Number 5 is a story problem. It says DJ makes beaded bracelets and necklaces. He has 2 storage boxes for his beads. The first box has 24 sections. So you're kind of picturing it. The first box has 24 sections with 12 large beads in each section. So there's 24 sections. Each section, each of those 24 has 12 large beads in it. Okay. So if I wanted to know how many beads were in that storage box, I'd just do a multiplication problem there. The second box, so now we're a whole separate box, has 48. It has double the amount of sections. And each of those sections has 25 small beads. So now I know what multiplication problem formula to set up to figure out how many beads are in that box. But here's the overall question they want to know. So we can figure out how many beads are in that first box, how many beads are in the second box. But what they want to know is how many more small beads than large beads does DJ have? So we got a lot of steps here. So 5A, it says, write an equation to represent this problem. Use a letter to stand for the unknown number. So that's what we want you to do first. And you're going to have to go back and look at it. But Mrs. G kind of set up the problem for you already, like how to solve how many large beads, how to figure out how many small beads. And then I'm pretty sure you just have to find the difference. Difference meaning subtraction. And then B asked, Maka got the answer. Oh, wait. Why don't I wait for that? Let's just look at 5A. So I want you guys to pause right now, look at 4A and B, and look at number 5A. Pause. And welcome back. Okay, let's go to the answer. I don't want to go too far down because I don't want you to see. I mean, just for your own math, I don't want. Okay, so here, I want to make sure you get the formula right for 5A before you keep going. But let's look at 4A and B. For you guys, the best estimation, the best is going to be 200. Why? Because it rounding, zeros are always 5 and zeros are always friendly to work with. So it looks like they rounded 29 to 30. So they took 30 times 7. Okay, and got 210. So the closest estimation would be about 200. That's close to 210. It's the closest. And then B, they say the best estimation is 51 times 39. And again, they use zeros to work with for estimation. So 50 times 40, just making the 51 a 50 and the 39 a 40. The best estimation is 2,000. Okay, so let's look at 5A. Here's an excellent formula. See if your equation, let me get rid of this. I wish this would just get out of the way. But here is really ultimately what you're doing to figure out how many, is this large beads? No, these are the large beads. This 24 times 12, this will tell you how many large beads. 48 times 25, that tells you how many small beads. And then look at the subtraction, then you have to find the difference. So parentheses, that's what you have to solve first. So figure out the product here, figure out the product here, and then subtract the two answers. And that tells you how many more small beads than large. So now let's go. Now you can kind of see if you got the formula right for it. Now let's continue through 5. So let's head back to this. I'm going to go down a little bit because if 5A yet goes 5ABC. Okay. So here's the whole. So now that you have the formula here written, 5B wants to know, Maka got the answer 2,000 more small beads than large beads. Is Maka's answer reasonable? Why or why not? So you're going to say yes or no to it's reasonable. Use estimation to help solve. So decide what you'd say there. And then C, it says use numbers labeled sketches, words to model and solve this problem. Show all your work. And in the end, I want to see if you'd get the answer correct in down here. DJ has how many more, you guys, small beats than large beats. So what was the answer to that first equation that you already saw how to write it? All right, pause and go solve. All right, welcome back. Now, let's go down and see what Bridges thought the best answers would be. So 5B, I don't want it to go too far. So there's the equation for 5A. 5B, it says McCaw's answer is not reasonable. So they wanted you to say it's, as mathematicians, it is not a reasonable answer. An example is it's just too high, because even if you rounded 48 times 25 to be 50 times 25, that's 1,250. And then 24 times 10 is 240. And you can tell that 1,250 minus 240 is way less than 2,000. It is not going to come close to 2,000. So ultimately, for your mathematical brains, you wanted to say it's not a reasonable answer. C, though, let's see if you got the correct answer. I really wish this would go away. I don't know where to put it. Let's just put it here. Okay. The answer is 912. When you solve 48 times 25, you get 1,200. 24 times 12 is 288. You find the difference between the two, and you would in fact have 912. Next page. We're in the third page of the test. All right. Let's go back here. Oh, I'm going to get out of this. Go to, look at, there's only 4 pages. And I can't stress it enough. You can pause it as long as you want. Take as much time as you need to solve this. Again, it's for you. Okay, let's go up. Oh, we're looking at fractions. Fraction action time. Okay, numero 6. Numero 6. Number 6. Shade in the bars to show each fraction and then complete each statement with greater than, equal to, or less than to compare the fractions. So 6A, you're going to have to draw it out, but you can pause. You can take your time. If you were asked to shade in these bars, this first one, and I'm going to use my little arrow here, 7/8. How many of these, that's divided into 8 parts, what would it look like to be 7/8? And this one, it's already divided into 6 parts. You want to shade in 5/6. And then comparing the two, because it looks like the wholes are the same. You just divided it into different parts. You want to compare these fractions and tell me, is one less than, is one greater than, or are they equal? Do the same for 6B, 2/6. This one's 1/4, and then compare. And number 7, it says sketch and name 2 fractions that are equivalent to 3/4. So you'll want to divide this not into 4 parts, but look at, you want to divide it into more parts and create a fraction that's equal to this. And same here. All right, go give it a shot. Welcome back. Let's go to the next page. I hope it works. Oh, good, you guys, it's right where we need to be. So number 6 says shade in the bars to show each fraction, then complete. Here's what they'd look like. You can see this is less, because if you had that line that comes down, the 5/6 is less. So just act like those are the same candy bars, same size. It's just you divvied the first one up into 8 pieces. You divvied the second one into 6. And if you had 7/8, and if you had 5 out of the 6, 7/8 is the route to go because it's greater. And look at the alligator mouth always eats up the greater fraction. Comparing these, 2/6 would look like this. 1 out of the 4, 1/4 would look like this. Clearly 2/6 is more or greater, so you eat up the 2/6. So sketch and name 2 fractions that are equivalent. Okay, so yours might look different, I will say. They chose 2 ways to do it. These are probably 2 of the most basic ways you could do it, but there are different answers you can get, so you're not necessarily wrong. If you can understand what I'm saying, you'll be able to check your answer. But they did it. Oh, Screencastify. They did it where they divided it into 8 here. Here it's just 4. So they did 8. If you divide it into 8, you'd have to fill up 6 of them to get to the same point. So it would be 6/8. Here they did 12 parts. And if it was in 12, each part is a little smaller. So you'd have to fill in 9. So these fractions are all equivalent to each other. And you could have done something different. You could have done, they just did each of these parts in half, so it makes it just a little more simpler to think through. They did these, but you could have done like 4 parts per it, and then you would have had 16 here and 12 filled in. So, I mean, there are different ways to do it. Those are just the 2 most basic. All right, let's go look at number 8 and 9. Numero 8 and 9. 8 and 9. Let's see what we got. Okay, this is last 2 on the 3rd page. Number 8, rewrite each pair of fractions with a common denominator. Common means they have the same denominator. You can use the fraction bars to help if you like. You don't have to. Then complete each statement with greater than, equal to, less than to compare the fractions. So you want to rewrite 2/3 and 2/4 to have a like denominator here, and decide which one's greater than, are they equal to or less than. And number 9, fill in and do the same thing with B. And number 9, fill in the blank with the correct symbols. You're comparing decimals and fractions. So you have to remember the rule of decimals, even how to read them. So 9A this is 7/100, this is 70/100. Don't let them trick you here. This is 48/100, this is 50/100 or 5/10, and so on. Remember, you cannot compare these fractions unless you understand what this means out of 100. So pause and give 8 and 9 a shot. All right, welcome back. Let's go down for 8 and 9. Here are the answers they were looking for on the test. So 8A looks like, and you could have done a different common denominator. Some of you may have done 24. You could have done 12, obviously. If you chose 12, this is 8/12, this is 6/12. So clearly 8 out of 12 is greater. So 2/3 wins. And over here, they also made it 12, because a 4 can become a 12 and a 6 can become a 12. So, and you could have done a different common denominator. 4 and 6, you could have done 24 also. You could have done 48. There are lots of different options you can do. They did 12. Again, there's less room for error when you choose the lowest common denominator. But anyway, if it's at a 12, this would be 9/12. This would become 10/12, thus showing 5/6. This one is greater. And 9A, 70/100 or 7/10 is greater. B, 50/100 is greater. C, 42/100 is greater than 40/100. D, 60/100 is greater than 55/100. E, 80/100 is greater than 78/100. And F, 90/100 is greater than 37/100. All right, last page. Let's do this, team. Okay, I got to go out. Last one. Let's see what we need to do. We are coming to the end. All right, make it a little bigger. Of course, this is in the way. That's cool. Let's just get it over there. All right, going up. 10. Joe and Carl each got a strip. Oh, you guys, a strip of bubble gum. Tape exactly the same size. Carl chewed 5/8 of his strip. So picture the strip, same size. Carl chewed 5/8. Joe chewed 3/4. You have to decide, so you're comparing 5/8 and 3/4. Which boy chewed more? fill in the blank, greater than, less than, or equal to, and how did you solve it? And then 11, let's just see. 11, you guys, it says label each of the marked points. Here are fractions, here with decimals. This is between 0 and 1. It looks like the segments are in tenths. So what two decimals could you write here? What two fractions? What two fractions could you write here? And what two decimals? All right, pause and begin. All right, now, welcome back. Let's look at the answer. I think I have to go to the next. You guys, which boy chewed more? Joe is the answer. 3/4 is greater. And you could solve it however you want. You could do fraction bars. You could rewrite the fractions with common denominators. They could both be 8 on the bottom. They could both be 16. Either way, there are many different ways to compare these fractions. You probably know how to do it if you got this and you got this. Looking at the bar down here, these are the two fractions, and you can have 10/100ths up here and 1/10ths, it doesn't matter. But these are the two fractions you can create, and these are the two decimals. So this is actually just 10/100ths. You're only 10, or 0.1 or 1/10. This is 60/100ths or 6/10ths, 60/100ths or 6/10ths. Now let's look at the last, is it the last question? Number 12, this is it. So Lupe says 6/10ths plus 23/100ths equals 83/100ths. Maria says 6/10ths plus 23/100ths equals 29/100ths. Who's correct, Maria or Lupe? How do you know? And how would you use this to help you solve it? Pause and give it a shot. Welcome back. Here we go. Lupe is in fact correct. Because you guys, 6/10ths is actually 60/100ths. 60 plus 23 is 83/100ths. So you could do it like this. And that is a wrap. That's not only a wrap for Unit 7, that's a wrap for you as mathematicians in the 4th grade. If anything was confusing, make sure you fill any holes. You can go back and watch any of the videos we've sent out if decimals are still confusing or fractions. Super proud of you guys. Thank you for watching. Thank you for trying. Thank you for being you. Have a great day. Bye, everyone.